Yeah, so I think I'll just kick off. So hi, everyone. Welcome to Wrangle's React Meetup. I am Natalia, the events manager here at Rangle. So before we kick off, I just wanted to quick introduce Rangle. So Rangle is a product transformation consultancy that partners with enterprise level companies and scale ups that need to innovate, and yet they have no idea how to start. So our skilled experts are obsessed with turning great ideas into reality and getting them to the market fast. And so we will be hearing more in details on how we do this with one of our speakers today. And so today we will be hearing from our special guest, Santiago, and our senior solution architect, Jason. So before I pass it over to our first speaker, I just wanted to let you know that we will be taking questions at the end of each talk. So without further ado, I will pass it over to Jason.
Hello, everyone. All right. Well, let me know if you've seen this before, right? You start your code, and after some years working on it, you start to feel like it's not really giving me all the benefits I want. It's like doing weird things when I try to change it. It's not giving me the speed I need. And it's to use a very nerdy joke, you see that outside, the world has changed. You feel it in the styling, you feel it in your build, you smell it in the code, right? So solution for you is like new technology. You go there, you throw away your old code, you start building everything again, and it's actually pretty awesome. You do things you couldn't do before. Everyone on your team is eager to test those shiny new toys, and you're there like trying to figure out which one of those should be the bulk of your new system. And at some point you organize things, you let your teams like contribute and decide what technologies you're going to use, all that. You trust that the best technology is going to win. And it eventually does, right? It's usually all right in that part. You select some awesome tools, and then it's business as always. You start shipping things, delivering, and like everything fits together. Sometimes there are slight differences here and there, but that's no big deal. Then your team starts growing, and your users start appearing. Like you get people using your system, the thing grows, and everybody's happy. You keep shipping. But then every now and then you start feeling that discrepancy creep in. Some things are being built in a different way because they have needs that sometimes the original thing you thought couldn't solve. Well, but you're still delivering, everything's great, you're delivering features, things are good for you and doing right. Now, fast forward another 10 years, and you have yourself a new legacy code that you will have to throw away. Anyway, my name is Jason Santos. This is me, and dressed in the way I used to dress when I needed to impress my enterprise clients in the time when we actually could meet them face to face. Now I can dress appropriately for my events, regardless of the level of enterprise required. I've been building software professionally for more than 30 years, and I've seen that thing happen a lot because of that. So I'm part of the senior technology leadership here at Rangle. I'm pretty sure you've heard of us. And today I'm going to tell you a little bit of some of the awesome things we did when we were partnering with SurveyMonkey to modernize their systems. But first, like, big disclaimer here. I didn't even come close to doing this alone. Don't imagine that I'm like Superman that can do that with on the tip of my fingers and just everything is fantastic and all that. No. I'm actually here on behalf of these amazing teams that really put all the hard work and the genius into making sure those things we tried and that actually worked, and especially those things that we tried and didn't work so well, but he told us a lot of things were actually very fast and very iterative, and more important, like that the synergy was awesome. It's like they accomplished this. I'm here just taking the credit. Right? Well, but like, let me tell you what the presentation is going to be about so you can have like the lay of the land. First, I'm going to talk to you about what the product is that we were modernizing and like what the plan was. Some of the key problems we found, like spoiler alert, local complexity, and the proposed solution for that, and some of the things that we did that actually worked really well for that. And of course, SurveyMonkey folks allowed me to show you a little bit of the code, so I'm going to show that to you as well. Of course, as SurveyMonkey, the SurveyMonkey team at Rangle knows very well, the presentation wouldn't be complete without some monkey puns that you can actually see around on the titles. Right? Well, about SurveyMonkey, what was exactly that product we were modernizing? It's one of the first examples of a software as a service in the market. It's like one of the pioneer companies on the Silicon Valley, and like they helped shape that industry by creating this survey software, right? Now they are big. That they have, I think, 1,200 employees, something around that, and more than 17 million users. Their product has everything survey and some other stuff as well, like market research, like online surveys, like competitive analysis, customer feedback, or even like things that you can use to have quick polls. It's a very big line of product and is growing. They have a large footprint on enterprise companies around the world. They use internal tools and customized solutions. And because of that, they had this huge impact during COVID. Right? They started empowering the communications between employees and all that good stuff that we are now forced to do from our kitchen tables and garages. So it's always great to have good software to do those things with. Right? Well, about Rangle, I'm not sure you've heard of them. Well, we're pioneers of the modern web. Natalia already told you folks a little bit about what we do, but one of the great things that we do is that we are passionate about making things better and making things digital. So at Rangle, you will have a hard time finding people doing super boring coffee and cake projects. Like we are usually called when people have tricky problems and they need fantastic solutions that are unique. We're a consultancy that was born in Toronto, Canada, but we now have a presence on multiple countries. All right, and that's what happened. Like they needed a very unique solution at SurveyMonkey in 2020, so we partnered with them, and the goal was to modernize the code base into this brand new shiny platform that they devised. That was actually super awesome. And they were facing a lot of challenges to do that, right? And it was like several different dimensions, like development, quality, the amount of effort required, communication required, all those things that migrations usually cost. But in their case, the sheer size of the product was one of the biggest impediments, and the complexity that they had. Right? The platform itself was fantastic, was really great. We were there like really impressed with the quality. Like it was well thought, it was using the best technology available at the time, and having one of the most mature DevOps practices we have ever encountered. It was absolutely amazing. But even with all that, like they looked like they were set up for success, they were still having some difficulties. For example, they had like this design system that was very good, cohesive, well-rounded. They had like good design principles. It was implemented already as a React component library with everything, with a cherry on top. But even that was not enough to get them to the speed that they need of adoption, right? So they asked us to join, to help, and we helped devise some of the goals that we ended up using to advance this thing and move this needle quicker and with better trade-offs, because that was the biggest problem that they had. Like, okay, we can migrate, that's it's inevitable. You just throw some code away and write some code that replace it in its place, and like try to put the seams in. But the problem is the things you want to gain from the migration need to be guaranteed. You need to really reap those benefits that you're aiming at, right? So the biggest problem is what you need to figure out. Like you go there and you need a problem statement, and that's what we found. Like by talking with them, right? How can we make sure the migration succeeds and reap all the benefits that we are aiming at? And we need to figure out what the challenges are exactly. So they had like this large code base. They had like a lot of feature teams doing very deep, very intricate work. And this intricacy was one of the key elements that actually created these difficulties. So the local complexity prevented us and them from easily scaling whatever it was that we were thinking of doing. We thought about doing something, and suddenly there were like 100 ways of doing that thing differently, all of them necessary, all of them with their caveats and trade-offs and requiring conversation across the company. What was the solution? We created for them and with them a domain library. So having a mature and well-designed design system that was called Range was a great idea. It was a great strategy. It helped the feature teams become more productive, created a cohesive look and feel for the application. It was great, but it was just the start. It didn't guarantee that the feature teams could just migrate after that, because that would not solve all the problems that they had. Once we went there and started having those conversations, we came together to the idea of simplifying as much as we could from every feature code by really assembling all the things that were related domain-wise in another presentation layer. And some of these business logic were pretty complicated. We're very deep into some of the things the users needed, and that we're talking about a product that has decades of age. Like it's been in the market for 20 years. So users expect that sophistication. So we drew from domain-driven design concepts, and we shaped a library that would concentrate everything related to one of the most important domains in SurveyMonkey, the question. It's a survey application, right? It's a survey product, the first one to migrate. So we created this central concept, and from there we started growing the ramifications. So a little bit more to the concrete side. How did we accomplish that, right? Well, the first thing we did, we started thinking, okay, let's put some process in place to make sure the goals are going to be achieved, and that we're going to learn the things we need to learn to be able to pull that off. So we divided the team into two different squads. Like, so in one part, the React developers could start delivering quickly as soon as we got like the visual requirements in and a good process around it. Right. In the meantime, another group started creating the relationships and the alignment with the feature teams and the central engineering of the team of the platform to help design the APIs, understand the problems, create GraphQL types and queries, integration points, and help shape how this integration was going to happen. Right? But that, if you put that in the front of your process, then you're paralyzed. So with the split, we could do this while the visual components that were actually organisms and molecules that were built with the design system, but that were domain specific and had other requirements, could be done immediately. So the sheer size of the migration was not a problem because of the delay. So the two tracks ran independently, right? So we had like two solution architects that were spearheading each one of those, but keeping in constant contact. So in fact, it was essentially one team, but they had the ability to concentrate on two different sides of the same coin. On the design system side, we have been able to refine and validate the governance model for the design system that could empower the feature teams and the domain library to both start contributing new things to that design system so it could grow into a more mature, even more mature structure that would be consistent with the actual new uses that we wanted to give by doing the modernization. Right? At the same time, by having that conversation with the feature teams, and we were able to bridge some of the knowledge silos, creating common understanding about things and how to structure the problems, how the structure of the actual application was. And one of the key elements was communication, right? The names were actually not consistent across teams. As they tried to solve different problems, they would call a section something else when the team was different. So we kind of normalized those names into this meta model, like the thing that could describe the entire product and that could be understood for all teams. And what happened was, that's the key for understanding it, is that we found a central place to discuss this dimension. The names we gave were not important. It's like they just needed to be the same, right? And the structures we started having conversations around were also not important. The important thing is that we now had a central shared understanding that was constantly evolving, right? One pattern started to emerge once we started doing this, and that to give all the features the flexibility they needed, like, and ensure a real platform that they could base their code in and their features in, to ensure that all the concerns were separated, and that would allow their new React teams to move forward both with the feature migration and the domain library. That was the three-tiered architecture. Actually, we took some inspiration from the capability pattern, but with some differences. And it was basically separating things into three different dimensions. One, the visual one, that was the visual components of the domain. They were not visual components as you would have in the design system, right? But those were organisms that were useful and that required knowledge that belonged inside that domain. So everything that needed knowledge around the composition and structures of a question would be sucked inside the domain library, leaving the features free to build things around other concepts that were feature specific. Right. The other one was the business logic that was specific to question types. Like SurveyMonkey has a product has like two dozens of question types or more, right? And each one of those has a fair level of complexity that stems from the product being able to do a lot of stuff. And these things were concentrated in this other layer that was like the question type structure. Like, and in the end, we structured it into visualizations and capabilities, these two concepts, in a way that could allow the feature teams to have a well-defined interface to really integrate their features with this library of domain without being locked into only one way of dealing with it. It needed the flexibility to implement some of the more sophisticated ways of behaving that their application and their feature had. In terms of deployment, we deployed this thing in 3 different libraries, like 3 different NPM packages. Like one library would contain all the visual components, like that would be dependent on the range design system. Right? The other library would concentrate all the business logic. This library was not React. That was a pure TypeScript library. So that was shared between the front end and the back end. That was also the place where all the validation logic, all the type guards, everything that required knowledge, deep knowledge of the intricacies of the internal shape of a question would live, and leaving the rest of the code being able to use the helper functions and the mechanisms to really help them isolate some of the changes that eventually happen from their own decisions that were like either visual or either integration wise. Like, and at the end, the capability providers in the question bundles, that was the bundle that was mainly consumed by the front end, had like the specific interface that the features would use, but they will also be able to participate in the creation of those that were implemented. Like for a certain capability, a certain API would be devised and will be present there. But that API and that thing was isolated from the actual visual components that will comprise that feature and the actual question types that would implement the business logic. Using that additional layer, that's the visualization. It sounds very complex, but it's actually not. It's not rocket science. It's just the slicing and the separation of each one of the concerns you would need to have, and each one of the moving parts that will evolve in the future to prevent them from starting spilling changes in a cascade to all the other parts. This is not something you would do for a small website, but for a massive product that will take more than a year to be migrated. This is vital. Otherwise, you'll end up having to do this again. All right, enough monkeying around, right? So let me show you a little bit of the code. The SurveyMonkey folks allowed us to show some of the code from the initial iteration of this. So some of these components are not final, but they show some of these concepts in practice. Right. First of all, we start with the tier 3. This is the smallest possible component you will find there. One of the things that we needed to do for them was to create some of the components as a separate thing, separated from the design system, because they had a different requirement. They were themable by the end user. This was quite a bit of a challenge in terms of concept, because at the end you have this awesome design system. Why not use it? But the conceptual difference was very, very determinant for this. Like if you have a design system, your goal is to make things look like that. If you want visual components that the end user are gonna change to match their own brands, so these components are probably not supposed to be part of the design system. So this is one of them. Like it's very small row layout. It uses some styles that are based on JSS, and you can see the implementation there of the style in the accompanying file that holds the JSS files and consumes the theme. Here's a little zoom in, so you can see like some of the implementation. Another example is like this simple text input. It's also themable, and it also uses a separate file for the JSS styles. Right. A little zoom, so you can see like the API, nothing super mysterious, nothing super esoteric. Right, a little bit down, a little bit down. So simple input with a bunch of very common and very usual properties, right? The glue that connects that visual component to the actual integration structure is what we call a visualization, right? It's structure designed to be one of the easiest parts to write and to use, and it maps whatever it is that the visual component needs, like it into whatever it is that the capability provider provides, right? And but this was one of the hardest components to name. But you know, folks, name is hard. Right. This is a little deeper view into it. It's essentially a big mapper, not a big, like it's a mapper that's specific to one question type and the one capability. It's supposed to be easy to write, so we provided a lot of tools, type to utils and utils to allow this to be done quickly. This is the rest of it. And in the end, it basically maps some of the things that happen outside to the actual visual components. It doesn't have a single div inside of it. Everything it uses, it's defined by the other tier. That's the tier 3 thing. And it's declaratively registered into the underlying mechanism, so allowing the mechanism to choose which one is gonna go, right? This is the capability provider. That's the interface with the actual feature. So the capability provider is essentially a collection of types and this interface here. That's actually super straightforward to write because it's almost kind of empty, but it's produced by this utils that we provided them. The types are the key, right? Because they will be born out of the conversation between the platform team and the feature team, and will design that thing to, okay, if you want to do a certain type of thing, like allow someone to fill a survey and write the answers to a question, what are the inputs you need, and what are the callbacks you need? Once this is defined and the capability is defined, the rest of the mechanism can take care of finding the right visualization and visual components to fulfill that. So this is basically it. That's just a few lines of code. It goes defining the types into and using the factory to create the provider, and then using React contexts, we create the mechanisms for the selection later on. Let me give you a taste of how it looks like. All right, so this guy here is the capability provider with something we call the controller inside. So based on the data that you passed into it about the question, it changes the entire implementation of the question type in the actual rendering. So the feature code doesn't need to do anything related to this. It just needs to implement each one of their own concepts. And when it comes to show a question in any of its forms, it will use a question controller and pass it the actual data. All right. But the code is super interesting, but it's not the critical reason for the success of this, right? It's the approach that makes the difference. And the approach is an example that has several characteristics of an evolutionary architecture, right? It's the idea that you need to make deliberate choices when you select your structure in a way that prevents you from seeping concerns into places where they don't belong, to like making very, very good decisions on what gets together with what. And it's organized in a way that looks into the flow of business, not the technology. Right? It's not about front end or back end, or this is visual or not. It's about, okay, what is the central concept that this application needs to work? Can we make things around it? Right? And also making sure your decisions are reversible. That's important. Like, so you build a function, you create something that can change APIs, that can change shapes easily, because you will need to change those frequently. All right. In terms of results, the migration is still ongoing, but one of the biggest results we had so far is the feedback of the engineering teams at SurveyMonkey. So one of the greatest indicators that they are really engaging with this structure, this approach, and this architecture is that we managed to get them involved with the evolution. What you've seen here is just the beginning of the solution, right? By virtue of having a structure that can evolve and it's intended to evolve, you can actually get those feature teams on board with contributing to it, not only to its code, but also to its architecture, and evolving by creating more solutions, because you didn't need to go deep into their local problems in the first iteration, right? You can embrace the new problems that they bring to you at a later date. And that's true also for visual solutions, right? If you have your concepts well structured from a business perspective, you now can change them from a design perspective more easily, because you're not married to structures that are going to change like this. All right, so the presentation now only needs a monkey punch, right? So let's go. And I guess, I'm not sure if some of you already heard that one. How do you call a group of very young monkeys that are siblings and keep yelling a warning at you? Months. I mean, this warning.
I laughed pretty hard at that before I realized my mic was off.
Well, thank you, folks. It was a pleasure. So I think I'll take questions now.
Hey, Jason, I had a question.
Sure.
By the way, great presentation. Actually, I'm at my workplace also, we are migrating our app from Ember to React. So this was pretty insightful. So I was curious, which previous technology did you use, especially the part that you migrated to React?
Well, it was, SurveyMonkey had a massive team, right, with several different features, and they had a previous policy that each individual team could choose their own technology. That means they had almost as many technologies as teams, right? It was all over the place. They have everything.
Thanks.
Okay, there's a question here. Are you also passionate about making things that matter? We're hiring at Rangle. Oh, I think this is a question from our own marketing part. So yeah, I think it's a question for you. If you folks are passionate about building things that matter, we're hiring. Yes, the slides and the recording will be shared after. Oh, marketing is already answering those. Okay.
Hey, Jason, I have a question.
Go ahead.
So those guys from the SurveyMonkey, they were already working with React, and you guys did like a full change, but still using the same framework, or I couldn't hear if you guys changed the framework as well. So that's my first question. And on the top of that, my second question was, why did you guys, because it seems like you guys created like a new shared component library for them. And I wonder, like, if you ever thought about going with web components and creating something more general, using stencil and wrappers for different like frameworks that could be in the future in other projects. So, like, this ever came to the discussion, and how did you guys, like, end up deciding what to do?
Yeah, when we got to the conversation with SurveyMonkey, they were using React in their new target architecture, right? They wanted React and CSS and JS to be the basis for their new platform. They were doing that already. The challenge was like how to make that migration succeeds, and that's when they brought us. We didn't devise the target technology stack, but before that, they had some features in React and some features in jQuery, some features in you name it, and they were not consistently sharing the same structures, so to say. So their intention was to have one structure to roll them all, a true platform that features would belong to instead of just npm import. Web components could be used to do that. They could, but that they just didn't do it that way because they didn't have the problem of wanting to give framework introducing framework divergence again. They were kind of burned by that, I guess. Right? Their idea was to have a stack that was completely consistent from end to end. They chose React for that, as they could have chosen web components as well.
Cool, thank you.
No problem. Right. Any other questions? I don't see anything on the chat. Okay, so if there's no more questions, feel free to send questions to our marketing on our email, or take part of other meetups like this. So I'm gonna give the mic back to our marketing so they can introduce our next speaker. Thank you all.
Hi, Jason. Thank you. It was a great presentation. I hope everyone enjoyed. So just pass it over to Santiago, who is our special guest.
Hey, how are you? I'm super psyched to be here. A little bit nervous, but I have some really good content to share with you guys. So the reason for my nerves is just, trying to get so many ideas into one place, and you run out of time. But I would love for this talk to be conversational. So I'll kind of guide the conversation. You'll see where I've been doing updates to some of the slides that I'll try to fix up before we move. I really hope that this will be an interesting conversation for intermediate to level to intermediate to senior to architect level JavaScript developers. Okay, guys, so welcome to my talk. I've been putting endless amounts of thought on this presentation, but beyond that, it's not like I had to come up with new ideas. These are things that have been solidifying year after year in my work as a consultant on many companies. So I worked on a number of different projects, and this is something that I live by now. So I hope that you'll take them as a humble suggestion of, like, what my experience has taught me. So a little bit about me. I work at Vaco Toronto, which is a consultancy primarily they're a recruiting firm, but now they want to get into the consulting world. I was one of their first leads to jump on a client and try to figure out how to accommodate their needs and solve their problems. Went reasonably well, so probably more projects to come there. I'm an absolute JavaScript nerd. I cannot stress this enough. Like, I know Python has better libraries, but it's the same as JavaScript, and I think the JavaScript syntax is gorgeous. Also, the community is really, really good. So I'm a JavaScript guy. That's like my I would get this tattooed. Now, open source, I've done open source. I did some open source with Rangle. I worked on Augury for a while. I know there's a new version now. But yeah, usually all the libraries that me and my friends put together, we release in the in our team GitHub, which I'll link to you. All right, so let's get started. So our goals simply has to go into a new engagement, for example, understand what the problem is, and then figure out what's worth doing and what isn't. But stepping back from that, right? Because that's our idea as consultants, right? Where is the value today with what you have in a kind of short term? Like, what are the low-hanging fruits? However, imagine this is your product, right? Imagine it's your startup that grew into to be Uber or something, right? So you're in control, and you have to worry about your business. So I actually see a very clear dichotomy between the goals that technical leadership has. So one is quality, by which I mean correctness. Correctness means never failing to provide the right outcome. Like, it doesn't fail to get something from the database if it actually should have been found, or vice versa. Like, it always produces, it does the job good, right? All the acceptance criteria are met. There's no complaints. All the unit tests pass. Now, performance is another thing that goes into quality. Like, you could make this machine that is written like with no thought whatsoever, or thought. You could have written the application purely thinking about how to make it as fast as possible and have a highly performant application. But that adds to the quality, right? So and robustness means, like, how often does you have problems, right? Like, if you deploy something, do you get users complaining that something doesn't work, or does quality assurance catch it? What is the robustness of our system? So quality is an asset value, which means it's today's value. So if I have this big ass computer right here, I'm sorry, excuse my French. If I have this big server computer, this mainframe, and it fulfills all three of these, it's never gonna have a bug. It's fast, and it does everything fine. What you have is a product that just has an asset value, right? Which means, do you want this thing that computes? For example, maybe it's like an AI machine, right? It's like a big mainframe special for neural networks, right? And it's done, right? That's what it is. Maybe it's a bit old, but it has an asset value. You can do things with it. Okay, but let me move to the more kind of interesting one, because I feel like as developers, we get hung up on the stuff on the left. And it's not fully our fault. It's somewhat our fault, but not fully. The problem is that the people higher up, the actual product management, right? The people in corporate that are usually hiring consultants, like, or Okay, basically all the way up the chain of command, the easiest way to look good is to show these things, you know, like, oh, look how fast the app is now, right? That's an easy win. It's a powerful win. Agility gives you what is investment value, right? So you could have this mainframe, right? But like, say you needed to add, you know, a different type of algorithm to it to make it better. Does it require a code freeze, you know? So if it's pure code freeze and nothing else, then all you got is some sort of asset value. And if you have agility, then you have investment value, which means if I get to know your company, go to your office, see what you're doing, understand your technology, see that your culture is right, you know, that you guys are doing stuff right, you're on the right trend, whatever, it has value in that I would invest in that at a pretty high rate, right? So you can't ignore investment value. Investment value can be converted into cash very easily at any time. So this is also valuable. The problem is that the right-hand side, people don't see as much. It's not so transparent, and the effects, the pains, are not felt until later, usually when it's too late to retract, and then you end up with serious problems. So what is agility? Velocity. That's like, you put a developer to work on something, how fast can he do it? But not just one person, the team, right? The agile team. How fast can we go through the Rangle, I forget what it's called, the Rangle flow, you know, and get it to production, you know? Cost. Like, maybe you can, you know, get it to production, but, you know, a junior could have been doing that same work, or it in order to get that velocity, you need too many people, right? There's many ways in which agility totally can, you know, interfere with cost. And then scalability, and I mean, agility itself is a word that is important here, right? Like adding new features, pivoting, being able to stay. Speed is very important. Well, that's velocity, right? Beating your competition. These are long-term goals, and you can't have what you. It's interesting because you can have one without the other in both directions, right? I mean, we've all heard about startups that have very high investment value. People have purchased them for ridiculous sums, but they don't have a product that's good yet. It's all promise. It's all look at what we can do, how fast we'll be, what are, you know, whatever. And this is the complete opposite. It's just like, I don't care what it is in 3 years. I consider it a depreciating asset. Okay, so basically, if you all agree, I hope I'm not missing one, but like, I think that quality, which is, you know, represented by asset value, and agility, represented by investment value, are the two goals to increase both of those KPIs. Our goals as engineers, right? And one of them is harder than the other because one of them is more visible. One of them gets you calls at night. But the other one makes your life a living hell and makes you, it's not just your life, like developers can't be productive, right? So anyway, let's do a fun little health check for agility. So these are kind of questions I ask. So I go to visit clients that, you know, describe their problem or what they're planning for the future, what they want us to kind of help solution for them. And I'm trying to get an understanding of like how it all works as a whole, right? How the organization, because the product is a whole organization, right? So, and these are things that have come in. I don't really ask these questions, but like they've come in my mind, right? So like, do you trust your automated tests? I've seen projects with 90% coverage where nothing gets committed without manual testing. At the company I'm working right now, we have the whole teams that's like what they do, right? And it's interesting because we have automated tests. It's that you can write automated tests in a wrong way, Automated tests, I've never heard a developer say, I hate unit tests. They don't make any sense. But they do it in a way that doesn't make sense and is counterproductive, in my opinion. And I'll get to that. Second item, sorry, how much time do I have? I think I'm going too slow.
You have until 7:20 or 7:30. That's fine.
Okay, I'm going to go really fast. Okay, so I'll just go through these quick just because it's kind of like, these are the problems that we're trying to solve with what I'm about to get to. This is all an introduction, and I've clearly wasted too much time on it. Okay, does new code tend to cause unexpected bugs, right? That's clear decoupling, clear side effects. Would an intermediate dev say that it's pleasant or frustrating? I find that the emotion that people feel when working is actually very distinct depending on the project. How much work is it to replicate and fix a bug if it comes from a user? Can you switch to that user's like context, or is it, oh, it works on my local, right? Do our development tools make it easier to debug or try out new ideas, right? So sometimes development tools like even get in our way. Like it's harder to run this thing you want, or it doesn't connect to the inspector properly, so you can't set debuggers. You end up using console logs everywhere. You have to have proper development tools that are simple and get the most bang for your buck. I guess I'll talk about that in a bit. And last three, do we have to read too much code to understand the specific behavior? I want to understand why, what caused my video feed to drop, right? Do I have to read the entire application because I did a Control F for video feed and it was all over the place? That's a bad sign. This one I think is super, super, like something that businesses do not get this value. They just don't. I mean, do peer reviews produce valuable insights? I really want during question period for you guys to challenge me on this, because I will be very happy to concede that they're not always. But what I find about peer reviews is that most of the, like, you have to think about how to do the solution. Imagine that's not like a well-maintained, it's a project with some technical debt, right? So you have to figure out a way to make that work. Now, the PR reviewer, is he going to reason about everything you did? Because I mean, it's pretty much doing the whole task again. So no, what they're going to do is just point out little syntax things, like use map instead of for each, right? And I mean, if you guys have opinions on this, please, I would love to hear it. And final and foremost, do we trust our devs, including fresh hires? And by fresh hires, I don't mean that like you toss them in and ask them to do something, but with some, leadership from his peers, that they will always commit code that will not be a detriment to our goal. So that means not compromising performance, quality, robustness, and also not breaking this, not going against the solutions that we're implementing to be cost effective and quick at building MERN applications. Okay, here's just a disclaimer, me saying, I've been saying this the whole time. Okay, general principles, finally. I hope I have, what do I have? 10 minutes? Man. Okay. Oh my God. Oh, Jesus, no. It's the old one. Okay, do you guys mind if I just, I pulled up the wrong presentation. Do you guys mind if I just tell you what I mean? Because the title should be explicit enough. And then I have some code that I wanted to show you and stuff, but I don't know, I guess I expect, time flies when you're having fun. So purity, we've all heard this term. Basically, purity is an avoidance of side effects. A side effect is something that changes the environment around you in any way. anything that like where things weren't as before, even for example, updating a Redux store, that's an effect, right? Things that don't have effects are pure, which means you can call them and they will do some work for you and give you back a result, but nothing's different. And this is a very powerful idea. Let me see if I can zoom in. No, I can't, but okay. Basically, you're guaranteed no effects. Okay, oh no, sorry, this is the definition. If you want to be pure, you have to commit no effects, right? In the course of your logic, for example, your function, you cannot, call an API. You cannot use external influences even. This is one that people miss. You can't just import a config file and put that in your pure function if you want to be pure. And I will argue that the more purist you are, the better, because you can 100% inject config into an application and actually have it run different ways for testing. Immutability goes hand in hand with purity, which all it's saying is never change a JavaScript object. Never. You just do a shallow copy, and that's it. And it allows us such cool, so many great things. Let me see if I can find you some code that will put this in perspective. So actually, before I do that, let me just say one thing really quick. If you guys heard the word purity, it's usually mentioned in conjunction with function, like pure function. I believe that term is misguided because immutability and purity are kind of similar, because they're both anti-side effects, right? So you can create what I believe, and it has been working fantastically for me, models that are immutable and have almost like classes. Object-oriented programming fell out of use because not because of the structure that it demanded, but because your objects all ended up maintaining their own state, and it became a nightmare to coordinate. If something went wrong, it's like, okay, what state is service A and service B in? Are they synchronized? Whatever, right? But and I'll show you some object-oriented code right now. Object-oriented pure constructs are just the best tool, in my opinion. So I will show you this. Okay, actually, yeah. Let me show you first. So okay, so I have an app here that it's in the middle of work right now, but okay. So our applications require state, right? And the way that state is done with Redux is you just define a whole bunch of reducers, a whole bunch of actions, but everything is very serialized, right? Centralized. Like there's no separation of concerns. I mean, there is as far as like you can separate it into files, but anybody can respond to any action, and there's no real configuration available to provide you power. So I'm going to show you the use of one of the open source kind of alternatives that we built, not to plug it, but just to show you what the API does for me in terms of project structure. So I have a behavior called perf monitor. It's a performance monitor. So in here, I have render watch dot. I guess we haven't gotten to service yet. Actually, let me just keep going. Okay, so I'm just gonna go down here to logic. Okay, so if you grab, for example, these are the logic operations, right? Every single one is a pure function. Like they will take something and return it. Great. Then, actually, let me show you something even. Same thing though, same thing. I'm not changing topics. Okay, so I have another example here. So here we have some queries. Oh, sorry, let me explain really quick the difference in language there. So when I say query, it means like a selector in Redux. When I say transition, it means like an action dispatch. Actually, this library is compatible with Redux. You can actually wrap it. But anyway, I'm not endorsing it. I'm just I wanted to make that clear. So say I have okay. So this is the definition of a query. It's saying, remember before when I showed you a whole bunch of pure functions? Well, those functions are the types that would be used in the implementation of this model, which is also an immutable model. So you never have to worry about your state having been updated somewhere else or anything like that. So in a query, we define a derived value function, which is super simple, like in terms of reasoning about it. We have arguments, we have the current state, and we have some extra stuff like provisions that get injected higher up in the line if you want. But basically, then we do a whole bunch of computation and we return the the result. So let me show you kind of what this looks like, because the power of it lies in debugging. The power of this. You might have noticed that inside the derived value function, I never reassign to anything. It's always step by step, and that is very useful when you want to set a breakpoint here and see at what step something went wrong. Should I do the sorry, let me find my screen. Okay, so let's move on from this one. Okay, so this one's they're going from like more obvious to less obvious, you'll notice. So they're gonna get more interesting as we move on. So law and order means every line of code should exist. Oh my God. Every line of code should exist in an implicitly defined, explicitly or implicitly defined kind of thing, right? This is, again, these are my principles, but I think that they make that people embody these principles anyway. I'm just saying it like it is. So basically, let me show you an example of that. So you can define kinds easy here, right? So I have logic. So for example, I have constants. This is clearly a different kind of thing than an operator, right? So, but these are very specific definitions, right? So the way I usually do it is all the way down the tree, I will have a kinds .md to describe the kinds that are here. Because not only are you describing how code can be added in this area, Well, that is what you're doing. But not only are you defining the type of data that gets created, the type of function or whatever, you also get to define the dependency chain. And unidirectional dependency is absolutely powerful. If I have time, I'll get some examples of that. But basically, we have constants, which are like at the bottom of the ladder, right? This file is not allowed to import anything else or use anything. Then operators have to be pure synchronous functions, and they're allowed to use constants, right? So there's a dependency. Where's my So there's a dependency from here to here. And these are just, but these don't do anything. Like we actually have some tests right here. Look what the tests look like. So I can test these. I'm going to explain what this is actually saying in a second, but obviously you can test a pure function, right? You just come up with some value for batch, come up with some value for buffer, and it will return to you value, right? However, there's another slide that I want to get to. So there's law and order, right? Like that means like the enforcement should be very specific. And if you are a good, if you are able to define a decent structure, for example, so we were looking at logic, right? What are the different files in logic? So we have operators, right, which are pure functions. And then I have stories. What are stories? There's some like random data here. And then I have test. That's why I have stories. Because in my test, I tell the story to do the work that I'm testing. Why? Because I'll just skip to that slide. Don't mock yourself. This is something a lot of people get wrong about unit testing. You don't want to, for example, so you have service A and service B, or it's a function. Function A and service A and service B, and service B is dependent on service A, so it needs to be injected, right, upon creation. But all your unit tests for server B are using this like mock version of service A, you know, because it's not only easier, but for some people, it's actually the right thing to do, because the test should only be testing that unit. That's why it's called a unit test. But I think that's not a great idea at all, because the job of service B isn't just to accurately perform its methods with the right inputs. The job of service B is to integrate with service A. So if something changes in service A, service B has to know about it. Another problem. So for example, yeah, so you could basically the problem I just mentioned is that you could have changed service A. Service B still passes all the tests, right? Because the mock hasn't been updated in their test files. But then you have a bug, right? So that's a failure. The other problem, not so much a failure, but it's like a rabbit hole of messiness, is always creating data literals. For example, that's seen a lot in Redux testing, where you're trying to test your reducer, so you give it a state that you like put together for that particular example, and then you give it an action with a type whatever and see what the new state comes out. But you're recycling. You're not recycling. You're not being eco-friendly. And basically what happens is that if you change some API, like now you have to change this thing everywhere, because that that hard-coded text is actually a representation of something you would have gotten from somewhere, right? So we have to mock some stuff, and I was gonna get to that. Some stuff has to be mocked because it interacts with APIs that have state that we can't control. So it's like state outside of our state. But for the vast majority of things, so here I'm just testing my logic for my state, right? And this is all just defining the, it's like the logic for my Redux app kind of thing. So I'm using stories. And what are stories? You'll see that in index.js, we do not export stories because stories are considered testing gear. So the problem is you don't want to build your application with the test and mock data and all that stuff in there. So what you do, or what I found is the best solution, is you have index.js as normal, but then you have a shared one where you add most of your stuff, right? It's only like 1 or 2 things that are going to be for testing. Most of the stuff you add in there. And then you have an index.js that just, outputs that, and an index.testing that actually merges that with whatever is allowed under testing, right? So then for example, in access, which is so logic here is the bottom tier. Let me see if I can draw this again. So it goes logic to access to queries to module type of thing, right? So access has permission to, and this would be all described in the documentation for the project. I want to show you so much more stuff, and I want to run some examples, but I think it's too late now. I had so many more slides, like yeah, accessibility, like you can run on Node or on the client. Okay, say for example, I have what's going on? Oh, it's this dumb thing. See, I have this other example. Actually, let's just grab what's here, what we were just looking at. So check this out. I have a folder here called Scratchpads, and this is one of the slides. Let me just go to that slide. Yeah, this one. Having fun should be easy, and everything the light touches is our kingdom. So what this means is, if I make a Scratchpad file here, and I have a script here to run Scratchpads, so that they, are able to resolve stuff properly. But using Babel Node, you can write your Scratchpads with full, ES7 syntax. And here you can just play around. So let me show you what this means, right? So if you define your state as a model, this means it's what Redux does as well. They're saying the definition of our state model is not, it's stateless, right? It's just pure. That's also the case here. But this is structured in a way that you'll understand in a second. So I have a query here. Common names between ages. Okay. So basically what this does is derive value, and it gets state, Rx. This is like calling, a regular thing. And these get provision. So then I go through the person's array. I compute this view with like, I count them by name, by count, whatever. And then I figured out, okay, these are the most common names. Let me show you this on Scratchpad. So I made it so that it allows me to provide a Scratchpad name, so we can have multiples and commit them to source control if we wish. Where did my browser go? Yeah, no, it's complaining about something that I was obviously what did I do? 1 second. This should be one second. It's complaining about this one. Oh, there's 2 state ones. Okay, yeah. I know exactly where that is, and I'll fix it immediately. Yeah, we're declaring state 1 2 times. Okay, are you good now? What is this complaining about? Anyway, I'm gonna leave this for now. So I'm just going to move that code away so it doesn't bug us anymore. There you go, behavior. So I'm going to remove this for now, just so we're back in sanity. And do a yarn test. Okay. So now the fun part, yarn scratchpad S1. So check this out. This is running in Node, right? This is not a browser. So this means that like you could be running an Express app here. You could be simulating anything that a node, like you could be writing a node service and do the same thing. So basically what you do is Chrome inspect. Chrome is the best tool out there for dev tools. Okay, so now it's just like, okay, nothing has changed. Let's change something. Wait a second. Sorry, I'm sorry, I got confused there because we ran Scratchpad, which is not tests. What Scratchpad does is beautiful. Look at this. So I said, run me Scratchpad 1. So it's this one, S1. So we can kind of read the code. But basically, the only thing we care about is making everything available. Just so to match this. Everything the light touches is your kingdom. If you take the advice that I will earnestly give you now. And never leave anything important, even if it's not going to mutate, but like some configuration, some value inside a function closure. Just don't do that, because it's better to put it as a property in an object that you might never see, and then be able to make more sense of what's going on and find that value, what that value is. If you're wondering, I mean, good luck getting to that closure. So anyway, this is where I am. I have a keep alive here. So basically we have you know what, I'm gonna do it from scratch just so you guys see how this, like, what this whole thing is about. So is anybody still there?
Yep, we're all here.
It's obviously very much past my allotted time here.
You still have 10 to 15 minutes.
Okay, I hope I'm not boring you. Okay, so let me show you something very similar from before in terms of what these queries are and how this works, right? So you can like have a query that defines its value, and then it can do other stuff for performance, right? It can say, for example, values are equivalent. So it provides a function that tells the engine, there's an engine at the end of all this, right? So, and that's always the case, right? Because at the end of the day, you're gonna have to produce effects. That's the, I mean, there's no features if there are no side effects, but you want to make all the definitions immutable objects that are identifiable and comparable to each other and stuff like that. So this guy is saying you can run, so imagine every time the state changes, which is actually true. So I wrap the Redux store, and you can subscribe to the Redux store with the handler, and it actually won't give you any data, but it will pretty much trigger your data every time that anything changed on the Redux store. So this is like the selector, right? And this takes a new state, takes my args, and I produce a new value for myself for this. It's like this query produces this value now. And values are equivalent means that, like, if by my own logic the value that I produced before is similar enough to the value I produce now, don't even bother anybody. Nobody needs to hear about this. I consider it an equivalent value. Same with this. Args or equivalence is actually a very important thing, which means if you create two models of the same type, right? Because this is a model. If you create two queries coming from the same model, how are you going to differentiate that they're different? Well, you use the type and the args. Okay, but I'm going too much on this. Let me go back to this Scratchpad fun. So GT is the name of this, state library that, it's the same as Redux. Everything we've been doing, you can do with straight Redux. So GT is like our stuff, right? So we have our models, right, that we're just looking at, queries. All right, well, we wanted examples. Where did that go? X, okay. So the way testing is done here is that there's full little example projects. So example 1, which is X, yeah. So we have some mock data, whatever. I guess that they use it. And then we have the same things as before. So we have queries, which are, so say for example, most common name by age group, right? Let's look at the test for that. No, this one's simpler. Okay, most common names between ages. So this is going to take an argument and the state, because the entire state module, the state definition, which includes everything, pretty much this X object is the whole state definition. It's all stateless. So, but I can say state is, let me see how this works. You're gonna do, what do they give it? Person registry. Okay. Okay, so we had that data thing. But like, see how easy it is to, like, if you start writing queries or functions that are all accessible through a tree dynamic, it becomes very easy to play around with stuff and to write your own new, like I could write a query right here, right now, right? Then when it comes time to actually put it into your code base, you have to follow the rules. Anyway, I'm not going to go too much deeper into this particular topic because queries, we understand, Redux, whatever. Let me tell you before I go about something kind of that I think is a little bit more revolutionary than this. I don't have a good example to show you, but I think you'll be pleased with this. Yeah, that's another important thing. You always use declarative, whatever. Okay. Okay, here we go. I hope you're all familiar with Redux. I mean, I guess you can't not be if you're working on the client side. Redux changed the world because it's brilliant. Because having all of the state in one place that you can, it gives you that accessibility that I've been talking about, right? The fact that I can like open up like all my models, like my state model, and create, for example, oh, I want a query for this part of the model, right? Whatever. It's like that for Redux, right? It you can always, look at what the state is or fill in the state. And the other brilliant part of it was the whole idea of you subscribe to map dispatch, map props to map state to props. And then you could basically just get yourself stuff. And however, for example, imagine you had, imagine getting that data was kind of complicated, right? You have a bunch of users, a huge list of users, and one component wants all of them, and the other component also wants all of them, but the second one wants to count them, for example. There's like, basically to solve that problem, you use something called reselect that you're probably familiar with. So you create a selector, but you wrap it inside another selector that basically says, if the outmost selector hasn't updated its value, then you don't even need to check. And there's a whole API to optimize these selectors. Well, I think let me explain to you how the GT store internals work really quick, and then you'll see what I mean by full stack Redux. So if I have, yeah, let me just uncomment all the stuff I had here so we can go faster. Okay, so this is the code that was run already. So the first thing is GT store, which is the library that contains the models, right? If I want to declare a new type of query, you use their API, right? GT store also provides the engine by which that I'm going to explain right now. So first you say store, and this is a very simple store. It's just an object. And then, for example, X is like the name of it's just an example, right? So we have a module called persons we created. So now we have a module persons here. The store can do interesting things now because if I type persons in here, you'll see that this is a module. See, GT module. Again, everything here, there's no state. Everything's immutable, whatever. It's just a definition of a type of object. So then we would go to queries, and we'll do this one, I guess. Most common name between ages. I feel like I'm kind of going in circles a little bit. Right, because they got it from the mock data. Okay, let's do that. So what a query, so this query is still not instantiated. It's a query model. So I'm going to say query. I don't want to make it confusing. So I can say that's kind of what it would look like. And then this would be the persons that this query wants to take. Oh no, they're putting that in the state. And then, but you can see like stepping through here, like each one is so self-sufficient, right? So we create a query. I mean, this is kind of confusing, but it's when you understand what this means, is so basic. You're just passing in provisions. One of the provisions is another query, whatever. But basically, what they did in the code that been used there. Let me just read what they wrote. And it's funny because every time I've said they in this whole conversation, I meant myself at 3 in the morning. So I do feel like a different person. But that guy, mad respect for that guy. So G is the global context, like window. So first we set the library there, then we set the example there. Then we can create a store. Then we can, let's put a debugger in here. Actually, we don't even need to because everything is in the global context. Okay, so we have some mock data people. And then here's where the store gets interesting. So this is the one that I was trying to use, right? Common name between ages. And clearly it actually didn't need parameters. That's what I was trying to figure out, like what parameters to send it. but I forgot that I added a bunch of defaults there. So let's say I'm going to put it in the global context. Let's say common names. Query. This is now a fully qualified query, I believe. Let's have a look. I'm gonna put it right here. So if I run the same thing we did then here, see what we get. Huh? Wrong one. Every time you restart the dev server, you have to this again. So, but that's the only issue. Ingest, it works magnificently. So yeah, let's just keep trying to make this query, right? So persons is the module which has queries. I'm going to create this query. What this creates is an immutable object with a bunch of definitions. And these are like everything you need to know to be super optimized. Like the engine is going to use these things to optimize itself, right? So it's not going to emit new values if the query says that the values are equivalent, right? Or there's two of the same query. You don't need to have two of the same query. They will just be shared. So the way that kind of works is like show you. Wow, this app is so crappy. I just want to draw. Okay, so imagine you create this query. This query is ready to go, which means like it has all the information it needs for the engine to be able to provide it its value. So I'm gonna do that as soon as this pink thing stops. Okay, so we had store here, which is the actual. This is a stateful side effect thing. This is a service. A service is what we call stuff that has a side that changes stuff. But let's say, for example, snap, and we'll give it Q1. So Q1 knows how to get its data, stuff like that. Let's see what it gives us. An empty array. Why? Because we probably haven't populated any of those yet. So like, let's try that. Here we go.
Santiago, just
Yeah,
sorry
are
to
we?
interrupt.
Yeah, are we done?
No, just sorry to interrupt you.
Oh.
With just a little bit over time. Do you want to take the next 10 minutes to questions? Or...
Yeah. I would love to just take questions. So basically, but can I just have 1 minute to wrap up where I was going with this?
Yeah, sure, absolutely.
So I hope you guys got the idea that with just pure functions, you can create immutable models, and then with the and you can set rules for what type of behavior goes where, etc., to keep a project from growing healthily. But then beyond that, your state definition can be like the state of your application can be pure, right? So I can have, when I called, this is my state model. When I called this function, what it didn't give me was a value. It gave me a query. It's like, go ask the store for this. I don't know, right? If I run this function, see it's saying store.apply. So for example, if I say, so again, persons is my module, right? So this is one of my transitions, add persons. So we're gonna add, but it doesn't actually do anything. It just gives me a transition, right? But if we give this to the store, it will actually perform the update, right? So it's extremely easy to test and extremely predictable. And not only that, it doesn't depend on anything. You have no dependencies on any library because you are not causing, you're not doing any side effects and stuff like that. Now, where I wanted to go from here is that this works in the front end because you always have access to all of your state. So whatever query I want, say my query is like super complicated, needs data from here and data from there. I mean, it is or it isn't, but it is what you see is what you get. That's the source of authority, right? And we've noticed also that it's very nice to you've all probably wrapped your components in Redux connect functions, right? To do all that, or use the state hooks or whatever. I believe the brilliance of Redux can be brought up to the next level of the stack and all the way up. So, because you can think of the database as the ultimate, it's like the Redux store for the whole system, right? The challenge that you fall into. So, oh yeah, and so in the same way that you declare, connect my component to, and this is my declaration of what I want from the state, you can also, you should also be able to do that about, data from the database, right? And that decorator should be, efficient enough that if 5 components are asking for the same thing, to optimize. Some people have tried this and they didn't live, like not physically, but they I don't know, nobody ended up, I mean, I guess it's still respected. For example, Apollo is one of the ones that still lives. But basically what you do is you have a component and you wrap it in a higher order component, and there you define a query. And GraphQL is all about this graphical data, right? Because all interesting apps right now are graphical data. You can't avoid it. However, the problem with that is like every component is getting its own version of the data. And even if you store it in state, you have all these duplicates, like different views of like, this different types of data. It's just kind of, it's inefficient. It's not, I've used this. It's not, doesn't solve the problem well. What I propose is in the same way that I declared what my queries and my transitions were for the client side store, we should be able to define our business entities that go all the way full stack. And then since that package doesn't depend on anything, so this is honestly what I do today, right? So I have Firework, which is like GT store, but it does what you would think, right? It subscribes to data instead, right? Let me show you a component. Yeah, so you can see services Firework Connect, right? And this looks very similar to one of those queries, right? From GT store, because they are. all this is returning, because entities is like the persons, like the module, right? Entities is just a pure model that you can give it some arguments, whatever, and it will give you back a query. And then Fireworks service will take care of dealing with that, right? The problem again is that we need to fetch data in an efficient way. But I think we've had the best solution to this for like 2 years. Here, let me see if I can have a slide for this. The atomic solutions. So obviously so much writing on this should have cleared out, but I've been working with atomic models as much as possible. This is my terminology, but I hope you understand what I'm trying to get at. So basically, here's the definition that I wrote. A model such that we are okay with always receiving the whole data. So you don't request for partials. And also a model such that users will have access to all of it or none of the data in that document. So it means breaking up, like denormalizing your NoSQL database, right? So for example, you have users, and users have, a little list of friends, right? But you want to know, like, what their name is, for example. So you have to go to the users thing, find what their name is, and fill it in. Well, what we're saying is we do none of that. So what Firework will do is, in the same way that GD store follows the same idea. So imagine, look at this. This is it. This is what I wanted to show you, right? And it's not that it's not the library. The library doesn't matter. It's the idea. So I have models here in the same way that this is a totally different library, totally different package. As you can see by the S, this is a sub module. So this is like its own repository, whatever. So in here, we define that, like, there's, different types of models you can instantiate, and the kernel is the thing that is stateful, that will actually do all the work, right? All the ones with an S are external submodules. Why? Because they're not specific to this project. Any project could use these. And working in a mono repo, when you have to, keep touching your open source stuff, it's actually a really useful thing. But the interesting part is this one. So underscore, everything with the underscore means that it's specific to this application. So here in the root model, it's just a class. Everything's just a class. And it's a different package than client DOM. Why? Because underscore lambdas also uses it, right? Obviously that's some old stuff or whatever. Yeah, look, Firework boot, and we're grabbing the entities. And then basically that allows us to do is, like, entities, actions, company, accept company invite, right? So you would have had that same state model. By state model, I mean something that represents the structure of the state, but doesn't actually hold the state. It's literally the same thing, right? So you could accept the company invite from your browser by just calling entities.actions, whatever. The obviously, to deal with that, you add rules, which is really easy, to not allow users to do that. And the reason this is effective, so I'm sharing the definition of what the model is, and this isn't like a Redux model for your browser. This is like the model for the centralized database, right? Now, what was it? Oh, no. This was my
Sorry, Santiago, we are way over time. Do you want to open for questions? Because I just want to be conscious about people's time.
Yeah. You know what? Yeah. Let's do that.
So if you have any questions, you can just drop on the chat or open your camera and just ask your question.
Santi, actually, I don't have questions, but I really want to thank you for sharing your thoughts and ideas. I think your health is not well, but still you are here. So glad, buddy, and appreciating your efforts. Thank you so much. Thanks
Thanks,
so much.
man. Yeah, it's hard to talk about these things and not, go back and forth and um, talk about everything all at once because it's all connected, but it 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 all makes sense together. Like this, the way you test this is so easy, right? And uh, anyway,
Yeah.
I have so much more to say. I had so much more content. I had another app that I wanted to show you guys. So I don't know, maybe next time in some other forum.
Yeah, sure, sure.
Yeah, you basically pull it very well against all the odds, I guess.
Sorry, what's that?
I'm saying you pull it really well against all the odds. I like the.
Yeah,
Oh,
well appreciated. Yeah.
oh, thanks. I appreciate it, man. Means a lot. I thought I was doing terrible because I had the whole thing planned in order, and it totally didn't pan out like that. But I had fun. It was just like a stream of consciousness, and I hope you guys got the general patterns that I'm
Yeah,
trying to get across here. Um,
yeah.
the way that you deal with, like, you have an immutable thing, but you need, something from a service is through like provisioning. So like, anyway, Sean, I'm not gonna get into that. You and I can talk later, whoever's interested. Yeah, oh yeah, here's actually, I want to show you guys the last slide because it's most important. Here are all, my contact infos. Reach out, if you have any questions and stuff like that. I love to talk to other like-minded people. If you have any content requests, I'm gonna keep, working on this type of content for a while because it's been it's been ingrained in the way that I conduct architecture design, but it's hard to explain it in an organized manner. I'm gonna keep going, but yeah, add me on LinkedIn. Send me an email if you're interested in connecting. Uh, I guess that's all for me.
Sure. Thank you.
Does anyone have any other questions?
Come on, guys, ask me a question. I love answering. I love debating.
Okay, so I guess that's a
Okay.
no. So thank you
Okay.
so much, Santiago, for joining us at Wrangle's React Meetup. So please don't forget that this meetup is being recorded, and I will be sharing this event into Wrangle's YouTube channel and our social media channels. So
Yep, that's
thank
fine.
you all for attending our event, and see you on the next meetup. Have a good night.
Okay. See ya.
Bye.